In the demo here, we are going to look at five parts that are parts of the solution that we have implemented for Seneca Foods. And firstly, we begin by looking at the IP addresses. We will we have implemented a block feature. This allows access to our system to those IP addresses that are not on the block list. Then we are going to look at our inventory, which uses a keylogger and it saves data that the changes that have been made in the inventory. After this, we will be looking at different properties that we have captured, which involve user, network, and device properties. These properties have been saved in a CSV file. After this, we are going to look at a file. We are going to look at multiple files that we'll be uploading on our website, and we will generate a report on this, like if it has a virus or if it is a safe file. And finally, we are going to generate reports that has data collected from all the properties that we have captured. So let's begin. So we begin by checking our public IP address, which is this, and we will log in first. So we can see that the login functionality is working perfectly. Yes, it is. Let's log out. And now let us make the changes to our IP address and display how the message looks like. So this file, which is dbconnect, we have added a condition, and if this is the query, which is this IP address, it will not allow the login. So let's try that again, and we will see an alert that tells us that the IP address has been banned. So let's move forward and let's unban ourselves to the next part. Uh, so here we log in, and this keylogger is saving the changes that have been made to the inventory. So let us have a look at that. So after logging in, we come across the dashboard page, which basically has an overview of everything that the company has. So you can see if what the items are in storage, if there is a deficit, what the revenue is. In the inventory page, we can view more about their products and its further details. And in the inventory log page is where we have our key log. And here, the changes that we make would be saved into an other file that will be saved locally on the website folder. So let's save this and let's have a look at the file that has been made. So if you look at this file and look at the time, you can see it's 5:55 and the date you can see it matches. It's just been created, and you can see that it has logged the changes that have been made over here. And we come back to the third part of our demo. So in the third part of our demo, we have actually looked on to different properties that we have saved, and we have captured user properties, network properties, and different device properties, behavior properties. So let us have a look at that. You can see that my local machine is in India. This is my zip code, and this is my longitude and latitude. This is my public IP address, and we just saw the same over here. And apart from this, you can see that I'm on 4G. This is my RTT, and this is my download speed. It's an Mbps. Uh, this is details about the driver, sorry, about the browser, and we find out details about the device as well over here. So we can find out that it is. Edge, and we know that it is Chrome based. It's We are running it on Windows. We can see that Edge is based off of Chrome, so its base is Chrome, so it gets detected as Chrome. I have given this virtual machine 4 cores and 8 GB, and it is displaying the very same. Apart from this, it also captures screen properties, which are the screen details and other details, and we can save the details that we have captured here into a file. And as you can see, it is a CSV file. So let us open that file, and these are the properties that we have just captured. We will upload a file on Seneca Foods, and we will check if that file has viruses. So let's begin. After logging in, we move to the page called user log. Here we see there are no files in the beginning, and we will choose two files one by one, and we will see their report. First file that we choose is this one, and we will upload this file, and that file has been uploaded. And so what happens here is that the file gets sent from here to VirusTotal's portal, where it scans the file and it gives us an output on whether it's a malware or if it is a normal file, or if it has viruses or not. So here we can see that the file will right. So here we see that the file has viruses reported, and it got 47 out of 67 positives, which means that it checked it against 67 antiviruses, and 47 of them found traces of something malicious. And we can see that here. So these are actually 47 antiviruses, and we can see that if what they believe is their analysis for that file, and most of them, as you can see, they will say that it's malicious. Um, and it is meant so all popular antiviruses that you can see here, you will see Symantec, you will see uh, Kaspersky, you will see McAfee, you will see Malwarebytes. All of these are pretty well known malware analysis portals. Oh, sorry, antiviruses, and they check for the file. So as you can see, it has gotten 47 out of 67. So let us look at the second file that was there, and this is a JavaScript malware, and this will also go through the same process as we saw earlier, which means that the file will go to VirusTotal's portal, and it will check it against multiple antiviruses to see if it has any malicious intent. And refresh this page. Since it happens in real time, we encounter some delays for about 30 seconds to 1 minute, but the file sends us a response, and as you can see here, so we can see that it has gotten 36 out of 59 positives, which means this file is also uh, a malicious in nature. So we see that it has been detected by different antiviruses like McAfee, you have Symantec, Avast, Kaspersky, the Defender, and we can see that its summary is visible, where we see that 36 out of 59. You're found positive.
So for the last part of our demo, we are going to look at a few generated reports. These reports contain data that have been collected from the user network and behavior properties of the client, and the code for the same will be included in the file for submission. And let us look at what they mean. Sorry. And we look at our property. So these properties would be what we would be looking at in the report. So after we download the same, we can see the CSV file, and from here we have extracted the values. So we begin with the first file. In the first file, we have uh, taken two attributes that are effective type and maximum touch points. So effective type is basically the network connection type, that is 2G, 3G, 4G. So the only two allowed types are 3G and 4G. So this would be the result for them. And the number of touch points. So the devices that have been deployed, they have 2 to 4 touch points. So anywhere below that or above that would mean that they have uh, it would mean that it's a fake user data and it's not the real user data. So looking at the real user data here, we see that right. So here we see that these are the value for the real users, and these are the value for the fake users. So for the fake users, we can see that the plot is a little more linear and there is only one anomaly over here, whereas this plot is scattered. Uh, now, so this is for the fake user and this is for the real user. Moving on to the next file. Out here we have taken two parameters that are device pixel depth and device RAM. So the devices that have been deployed in the system have two levels, two options for pixel depth, that is 16 and 24 byte, and the acceptable RAM is 10, 12, and 16 GB. So as you can see, the use case for the same is visible over here, and they are linear in this case. Whereas for the fake user, we can see that the values are different from the ones that we have obtained over here. And this plot, on the other hand, is non-linear, as in you can see that it's scattered. And we move on to the third file. In the third file, we see that we have taken two other properties that are device color depth and the number of cores. So the two acceptable values for device color depth are 24-bit, 16-bit, and for number of cores is 6 cores and 12 cores. And we can see that again there is a linear representation of the same and a scattered representation for fake users, as they have values anywhere apart from 24, 16, and 6 and 12 over here. And so, what do these reports tell us? They basically help us in differentiating between the real user and the fake user. These reports are generated on the basis of data that has been collected real time from the properties that have been captured using JavaScript. And what this basically implies is that we have uh, this helps us in this helps us in strengthening the system against attacks, and it does so by reducing the attack surface. So by telling our system what by telling our system what is the real user use case and what is the fake user use case, we can effectively find out if there have been any attempts, and by mapping out the data, we can find out if there have been any attempts to break into the system, or if our device security or if our system security has been compromised. Thank you.